Now we are moving on to something called proportion. Guys, let me give you a basic idea. I'm going to play a video for you guys so that you understand proportionality in a more imaginative way. Alright. To give you a basic idea, I have two ratios. And when I equate those two ratios, I say that they are in proportion. For example, say I have A is to B and I have C is to D. I am talking about the equality of two ratios. What does it mean? Let me make them equal. I'm saying A is to B is equal to C is to D. Now how can I write this? A by B is equal to C by D. Or it can also be written as A is to B is proportional to C is to D. This is how you write it, or this is how you represent it, or this is how you say it. Alright? Is this clear? Now, what does he say? He's saying the product of the means is equal to the product of extremes. Let's understand this and then I'll play the video for you guys. I have A is to B. If I say proportion, that means I am talking about equality. That means I'm equating the two of them is equal to C is to D. Now, these two numbers are called means. B and C are called means. Now, A and D, sorry, are called extremes. Why? Because they are the corners basically. That's the reason he's calling them extremes. Now, why does he say that the product of means is the product of extremes? Simple logic. If I have A by B equal to C by D, when I have an equality sign, I cross multiply. We are doing this from simple equations, if you guys remember our first ever session. Cool. Everyone's following till here. So what happens when I cross multiply? I get A into D is equal to B into C. What is B into C? Means. What is A into D? Extremes. Isn't the product of means equal to the product of extremes? Is the derivation very clear? Is everyone clear with this concept? Quickly put in a yes or a no. I have to play a video for you guys. Unma and Priscilla said yes. What about Arna, Bhavya, Vatsala? Chalo. Now let me play a video for you guys. Can you guys see the screen?
Sir, we can, but you muted it.
I muted it. I haven't muted it. I paused it. I want to make sure if everyone can see. All right?
Yes, sir. Now we can see.
Yeah. Okay. It's a 4.5 minute video. Watch this carefully. You will get an imaginative idea. You will get a very good understanding of what proportion is.
Concept of proportion is very simple.
Is the audio clear, guys? Before play,
Yes, sir.
All right. Cool.
Sir, I think you should mute yourself because we're getting an echo.
Yes, sir.
You should mute yourself, sir.
Yes, sir. So,
Yes, Bhavya.
so can we say tell that those four dots in the middle in between two ratios? Can we say that, for example, we say 4:7 is proportional to 8:6? Can we say that?
Exactly. That's what we have to say. Did you guys understand what proportionality means?
Yes, sir. Equivalent.
Right. Priscilla, Arna, have you found a better mental picture about what proportion is? Right. That's the reason I showed you the video. That's what I explained on this slide. If you can see my screen now, this is what we discussed. Product of means is equal to product of extremes, and that was the video to give you a better imaginative picture. Now look at this concept, guys. This is something called continued proportion. Now, what is continued proportion? say we have three quantities. Pay attention, guys. Say we have three quantities, A, B, and C. All right. And if I say such that the ratio of the first two quantities, all right, and the ratio of the second two quantities are in a continued proportion or a continued ratio. All right. A, B, and C are our three quantities. If I'm taking the first two quantities, I'm going to write it as A by B. And if I'm going to take the second two quantities, I'm going to write B by C. Now, which is the common one, common to both? Isn't it B? When I equate both of them. This is called continued proportion. Now, what else can we derive from here, basically? When we have an equal to sign, we cross multiply. So A into C is equal to B square. All of you agree? How can I write this as? B is equal to root AC. We're going to come to this concept in the subsequent slides. But is this clear? Is continued proportion clear? If I say A, B, and C are in continued proportion, that means A by B is equal to B by C. I'll clear it, Bhavya. Don't worry. Now, what if I say A, B, C, and D are in continued proportion? Instead of three quantities, I got in four. That is nothing else but A by B is equal to B by C is equal to C by D is equal to so on. If I have E, F, G, but it stops over here. A by B equal to B by C equal to C by D. Is everyone clear? Bhavya, what's your doubt? What about the others?
Sir, I didn't understand that continued proportion.
Why did?
I didn't understand the continued proportion part.
Okay. What is proportion? Proportion means we are equating two ratios. So what do we have? A by B is nothing else but A is to B. B by C is nothing else but B is to C. Was that clear? So what we talk about proportion? Product of means is equal to product of extremes. We just
Yes,
proved in
sir.
the previous slide. So A into C is equal to B into B. It's the same thing. Instead of having A, B, C, D, we had A, B and B, C. That is where the continuity is established because we have two common terms. B is common to both the ratios. That is the only difference. The logic hasn't changed.
So if we substitute it with, like if we write A, B, B, C as A, B, C, D, so it will be the same like B and D, B and C are the means and A and D are the extremes.
Exactly. Product of means is always equal to the product of extreme. Just because I change the letters, it doesn't mean the concept is going to change, right? The concept is the same. Is everyone clear? What about the others? Priscilla, Umana, have you guys gone to sleep or what? Can I move on to the next slide? All right. Now, remember I wrote this, then I wrote product of means is equal to the product of extremes. So I wrote A into C is equal to B square. So B is equal to under root AC. That is exactly what he has explained under mean proportional. So B, that is the one that is common to both of them, he says is called the mean proportional of the other two terms A and C. This is how you find it. It's nothing else but multiply A and C and then find the square root. That's the only difference. That's the reason I have written this on the previous slide, because I knew that the next slide was an extension. Alright, is everyone clear till there? Is everyone clear?
Yes, sir.
Let me explain something to you guys. If I give you let me give you two ratios. One is 2:3. The other is 4:5. Alright? Now, how can you convert this into a continuous form? How can I make them equal? In a lot of concepts, it's going to tell you A is to B is 2:3, B is to C is 4:5. My question is, what is A is to B is to C? Who can apply what we just learned?
Sir, I think like we have to first multiply A into B and then we have to multiply C with it.
Okay, Priscilla, what do you have to say?
2:3 is equal to 3:4 is equal to 4:5.
Okay, so what would A is to B is to C become?
Sir, can you repeat?
What would A is to B is to C become? You've given me three ratios now. I just want A is to B is to C. You've given me A is to B, B is to C, C is to D. I don't know how you got that, but I just want three numbers. A is to B is to C is the ratio I want. What can we do over here? Think logically. What is common to both the ratios?
B.
Right.
B is common. B is common.
The first ratio, A is to B is 2:3. And the second ratio, B is to C is 4:5. Say B is to C would have been 3:5. It would have become 2:3:5 directly. But over here, because it's a common term, it cannot be different. That means these two terms have to be the same.
Yes.
Right? How can I change the ratio? I cannot. It has to be the same. That means, how can I make B equal? Say, I multiply this by...
Sir, we should multiply 2:3 with 4 and 4:5 with 3.
Perfect. So what do I get? I get A is to B as 8 is to 12.
8:12.
B is to C as 12 is to 15.
Yes, sir.
B has now become common. So what will A is to B is to C now become? 8 is to 12 is to 15. Is the idea clear? Is the logic now clear? When we have a common term B, how can it be different? It has to be the same. If we make it same, we have to change all the others also accordingly. That is how we made B equal to 12, because of which A and C also changed, because that's a common multiplying factor. Now we get A is to B is to C as 8 is to 12 is to 15. Is everyone clear with this? Bhavya says he did not answer. What about the others? Priscilla, can you explain it to Bhavya once? If he still doesn't understand, I'll explain at the end of the class. Don't worry. Priscilla,
Yes, sir.
Priscilla, can you explain to the class and Bhavya once again?
Yes, sir. Understood. Sir, now we have A's to B and then we have B's to C. So A's to B is 2:3 and B is to C is 4:5. But B is a common element here, but in one of the ratio it is 3 and another of them it is 4. So that cannot be possible.
Right.
So we have to make these proportions equivalent to each other.
Perfect.
So if we take the LCM of 3 and 4, it is 12. So 2:3 in as a whole, you have to multiply it by 4.
Perfect.
Because B we have to make it 12. So we get 8:12 and 4:5 we have to multiply it by 3 and we get 12:15.
Right.
So then as now B is a common element, So we can write A is to B is to C. That is 8 is to 12 is to 15.
Perfect. Bhavya, are you clear now, or are you still do you still have a doubt?
No, sir, I still did not.
Okay, don't worry. Wait at the end of the class. I'll explain it to you. Don't worry. All right. Take it. Now, the heading says fourth proportional, but we have something called first proportional, second proportional, third proportional, and fourth proportional. This is the first proportional. This is the second proportional, third proportional, and fourth proportional. Is there any rocket science over here? Yes, Arna, tell me.
Nothing, sir.
All right.